Hi there, I'm Nix, and today's video is a continuation of my Getting Started Easily on LeetCode playlist. And as you can see, we're going to solve the richest customer wealth problem on the LeetCode website. In doing so, I'm going to give you all the details of solving the problem, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities, as well as looking at the LeetCode rankings. If all of that sounds interesting to you, then stay tuned. Welcome back, and let's get right into it. We are given an m by n integer grid called accounts, where accounts ij is the amount of money the ith customer has in the jth bank. We want to return the wealth that the richest customer has. And then we have some additional information. The customer's wealth is the amount of money that they have in all of their bank accounts. So essentially it's the grand total. The richest customer is the customer that has the maximum wealth. Alright, so in example 1 here we have accounts, and it's an m by n grid, or in C++ it's going to be a vector of integers. This is one vector, this is the second one, and this whole thing is the vector that houses each of these two individual vectors. Now our output that we want to do is 6, because the first customer is essentially this first vector, and all the values in here are his individual amounts of money in each of these 3 banks. So bank 1 has a money unit of 1 present in it, bank 2 has 2 units, bank 3 has 3 units. Now to get the total wealth that customer has, 1 plus 2 plus 3 is equal to 6. You do the exact same thing over here, except for this customer, bank 1 has 3 units of money, bank 2 has 2 units, and bank 3 has 1 unit. But of course that also sums up to 6, so for this particular example, both of them are tied. The maximum wealth that a customer has is 6. Example 2, very similar thing. We add up all the values in each of the vectors to see what the grand total is. The second customer has a sum of 10. That's the highest wealth when comparing to the other 2. So that's the one that we want to report. And so on and so forth. In constraints here, nothing too interesting. We're going to have some small range of money values present, and our grid is going to be anywhere from 1 to 50. Alright, so how do we go about solving this problem? Well, in going through the example, we see what we basically have to do. We have to go through each individual vector in the grid and sum up everything that is present in that vector. Add up all of the integers. So we essentially have to do 2 loops. We have to loop through each inner vector and add up all of the values present in it, all of that money. And we also want to loop through each of the vectors that are present in the vector of vectors. And we need to record 2 key pieces of information. 1, what the total sum is when we add up all of these values. And our other key piece of information that we need to record is what is the current maximum wealth present. And at the end of our loops, that maximum wealth that we record is going to be our final answer that we want to return. So to sum up the general plan, we need to make 2 variables, one to house the total, one to house the maximum wealth. And then we're going to have a nested loop, because we first need to loop through all of the vectors that are present in the vector of vectors. And we also need to loop through each of those inner vectors to add up all of the integers that are present in it. After we add up the total for each vector, we want to compare that to our current record of the wealth. If that current maximum is less than our total that we've found, then we need to substitute that value and make it the new max. Then we just reset our total count, move on to the next vector, add them all up, and do that over and over and over again until we go through the entire grid. So with that plan, let's move on to the code. First up, I have an integer variable that I call total money, and I set that initially to 0. And then I have another integer called richest wealth, and I set that to -1. This is essentially so that I've set it to something that it cannot possibly be to guarantee that it's overwritten. Next up is the first for loop. And for variety's sake, I went ahead and am using the ranged for version. For this, the loop is going to go through the vector of vectors, and I want to go through each of those inner vectors that accounts holds. So in order to do that, I specify a type. Now I could have just written vector of integers here, but auto accomplishes that. Essentially, I'm telling the compiler, you figure out what this type is for me. I accomplish the same thing, but with less typing. This is really useful when you're dealing with much more complicated and long types, where you, let's say, made a custom object that is very long to type. Auto is very useful. Now, for the account that is present in accounts, with the accounts being the grid, I want to do stuff. The very first thing I want to do is do another for loop. And again, it's a ranged for loop. Now that I'm dealing with those inner vectors, I want to go through and in this case, I've specifically spelled out that the type is going to be an integer. And for that integer value in each account, I want to, again, do stuff. And what I want to do is the total money I want to set to itself plus that value. So this for loop is going to go through each value and add each of those values to the total money and sum it all up. And it being nested within this for loop means that this loop is going to occur for every single account that is present in that vector of vectors. Every single count in accounts. Next up, now that we have the total money value for the account, we want to do the comparison and see if that total is now bigger than what our richest wealth is supposed to be. So if the total is higher than what's supposed to be the maximum, then we want to set richest wealth to equal the value of total money. After this comparison has been done, now we want to reset total money back to 0 so that we can start fresh and add up the values in the next account. Because after this, that outer for loop is going to be done with an iteration, loop back around, and move on to the next account, where it will then go into this for loop, add up all the values, do the comparison, reset, and then move on to the next account. It's behavior that's exactly what we want. Finally, outside of all of the loops, we want to return richest wealth. And with that, the code should be complete. So now moving on to the button clicking phase of things, I should see no issues and lovely green text, which is what I see. So with this test case, everything works out hunky-dory. Let's go ahead and do the submission and see if it passes all of the test cases, which it does. Great. Now let's go ahead and analyze the time and space complexity of this thing. Well, we're only using integer variables that set aside constant space. And the only thing that we're doing within the for loops here is doing simple constant space things. So in terms of space complexity, this would be a big O of 1. It will use constant space to do. In terms of time complexity, well, in order to figure that out, we need to look at this nested loop. Now you might think, oh, nested loops mean n squared time complexity, right? Not always, but that is a general good rule of thumb to use. So let's look at it and see what we see. This inner for loop is going to go through each value in the account. In other words, it's going to go through the size of the inner vector. The bigger that vector is, the more iterations must be done to loop through it, and thus it's going to take more time. So we can specify that as, say, equal to n being the size of the account. The outer loop is going to go through and iterate through all of the account in the account's grid. And again, that is dictated by the size of that vector of vectors, the size of accounts. The more vectors you have in this outer vector, the more iterations it needs to run, and the more time it takes. Now we could call that m. The size of the vector of vectors is going to be equal to that letter. And since they're nested within each other, this is going to mean that the time complexity is going to be akin to a big O of m times n, because you have, say, in the description here, m times n. Now, if this is always guaranteed to be a perfect square, i.e. m and n are always the same, then that essentially reduces to one variable, say n squared, and then you would have what you would expect, a big O of n squared time complexity. If m and n were different, you couldn't reduce that any further. But for this problem, it seems that it's always guaranteed to be a perfect square grid, which means we can reduce it to what we are expecting, big O of n squared, which isn't the best, but due to the nature of this type of problem, where we can't really get around having to go through each of the accounts and having to go through each of the values in order to achieve what we want. This is usually the answer that probably immediately pops into your head. Final thing to do is see the rankings here. But you can already see this is essentially the exact same thing, exact same code, but you can see a huge difference in terms of runtime, but not too much difference in terms of memory. But let's click on these things anyway, and it has me way down here. And if we scroll down, we have no indicator, but we're kind of somewhere around here, being 8.1. I think it was 8.1 in the previous page. So we're somewhere around here, but it varies widely, as you can see. Going back here, again, these two things are the exact same code, and I can prove it by clicking here, going down. See, here it has me at the top. It still didn't have any issue here, but you can see this is the same code that I showed you, and yet I'm here at the top of the pack in one instance, and I'm way down here during the recording of this video. So, as I usually say, take LeetCode rankings with a grain of salt. Now, with this problem under our belt, I think I'm going to start tackling the linked list explore card and working through some of those problems. And depending on my scheduling and how things work out, I will do occasional problems to add to this playlist, the Getting Started Easily one, and work on problems that are on the linked list explore card, depending on my time availability. So that's what's in store for you. I hope this video helped you out and was useful for you in some way. If it did, consider subscribing. And with that, I will wish you happy coding and to have a nice day.